For part G, I will not do the full solving process, but I will get you started with the visual, and the rest of it will become really, really obvious because you will be using the same technology to help you get those numbers. So we're looking for probability that z is greater than some mystery boundary and z at the same time is less than 0. And this combined compound interval has the probability of 0.3531. Let's start with the part of the interval I do know. I compare z-score to 0 and I have a less than there. So I start at 0, separate a chunk of area, and I go to the left. So notice I shaded in red everything to the left of 0. That's what this interval tells me to do. There exists the second interval. I'm not sure where this boundary point should be for sure. However, I know I'm going to go to the right. So I am guessing it should be here, and I shade everything to the right using different color to make it easy to distinguish which interval we're talking about at the moment. How did I decide to place this unknown point exactly here and not closer to 0 or further away from 0? Well, look at this quantity here. We're told that the intersection of these two intervals should be accounting for about 35% of data. So this point is placed strategically here so that this chunk where both intervals meet, the intersection, is around 35% of the entire area under the curve. That's why. Now your job is to find the z-score that makes it possible. To compute it, it's actually really easy. Notice that you already know the entire area to the left of this 0. It's 50%. And if this chunk, portion of that 50%, is 0.3531, you can easily subtract them to find this chunk on the left side of this mystery point you're trying to find, and then use this amount of area to find this point, separating that area on the left side from the rest of the area under the curve.